I think we are going to have probably a test on Thursday or Friday. Actually, it's going to be on Friday. Okay, so and chapter 10 is usually kind of tricky for kids because it's got probability involved. It also has the tree diagrams, which leads to the fundamental counting principle is what they call it. All right, and again, I used to think that the tree diagrams were kind of silly, but after I did it enough, it helped me understand more about probability. All right, so I'm going to try to emphasize with you today drawing a tree diagram, and I specifically remember doing tree diagrams last year also. All right, so I know we've done it. So this year should be a little bit easier. All right, and it should be, it should help you with what's referred to as the fundamental counting principle. All right, but I want everybody to put your eyes up here, try to concentrate. We're only going to get started today. We're not going to really be able to finish, I don't think. We have a shortened period because of the club day. So again, please pay attention today. All right, it's very important. All right, and then again, these have to do with finding all the different possible outcomes. So up here, the first one, it says when you flip 3 coins. All right, we want to draw a tree diagram, and then we want to find the total number of possible outcomes. Now, can anybody tell me from last year how many possible outcomes there are when you flip 3 coins? There are 3 outcomes. Anybody else? There are actually what? 6. Anybody else? Anybody else thinking about it from last year? There are actually 8 different possible outcomes. There's 8 different possible outcomes. Now, what your understanding of outcome may be different from my explanation. All right, so I want you to understand. All right, when you flip a coin, you can only get a what? Heads or tails. So how are they 8 different possibilities? All right, there's just different combinations. That's exactly the correct way to say it. So what I want you to do now is I'm going to show you how to draw what's referred to as the tree diagram. How many times are we going to flip the coin? 3 times, okay? So here's what I want you to think about. All right, in a tree diagram, here is your first toss. All right, in your first toss, you can get either a what? Heads or tails. So we're not going to spell the word, we're just going to write H, and then we're going to write T. All right, that's your first flip. Everybody with me? Now, you're going to flip it a what? You're going to flip it a second time. And when you flip it a second time, here's what I want you to think about. You can get either a what? Nope. You can't get the same thing when you flip it. You can either get a what? You can either get a head or a tail. So what I'm going to put down here is your option if you get a head and your option if you get a what? Tail. And then we're going to get a what? Heads or tails again. All right, that's your second. Now we're going to flip it a third time. All right, so here's what I want you to think about when we flip it a third time. This over here. Bless you. This guy right here. This guy right here. And this guy right here. This is what's referred to as a tree diagram. Okay? So now, when you flip it, you can get a what? Heads or tail. So, heads, tails. Heads, tails. Heads, tails, heads, tails.
I think that's pretty simple.
Now, how did I get 8? Remember at the beginning I told you there were 8 possibilities. How did I get 8 now, Aiden? Yes. Count the final. How many are down there? 8. That's why they're 8. But that doesn't really help me. All right, that doesn't really help me understand what happened. All right, so now this is what helped me. Look up now, guys. I want your attention up here on the board. All right, so when you flip a coin 3 times, your possibility is what? Those lines. That's exactly right. So one possibility is to be what? That's correct. Everybody with me on that? Now what I'm going to do is I'm going to come down here, and the next choice would be H. Uh-oh, hold up. I went the wrong direction. My fault. It's H, H, and then what? And then T. Does everybody see that? All right. So again, you're just recognizing the patterns. H, H, T. Now, I'm just going to get a different color for you, just to make sure. No. Heads. Can I go any more down here?
No.
Because there's not a different path. So I have to go heads to what?
Tails.
And then from tails to what? Heads. So here we go. H, T, H. And then if I put another one up here, heads, tails, and then what? Tails. And now we have to start with the what? We have to start with the tails. So it could be tails, then what? Heads, and then what? Heads. So T, H, H. Then what? T, H, T. T, T, H. And then T, T, T. And guess how many outcomes there are there? 8 different possible outcomes. All right. Now, again, I know it sounds kind of silly, but believe me, I used to tell kids I didn't really like showing kids that because I think it was kind of silly. But it really helped me understand probability much better. Those are all the different possible outcomes. So when somebody says, what's the probability of when I flip a coin, I get 3 heads? What's the probability if I flip a coin, I get 3 heads? 1 out of 8. Exactly. Right? Because I have them listed. There's only one way I can get what? All heads. All right? What's the probability that I get 2 heads? 2 out of 8. Tell them. There's the HHT and the what? And the HTH.
So yeah, the 3.
Oh, yeah. And then there's what? Thank you very much. All right? So it's not 2 out of 8, it's what? 3 out of 8. All right? Say that again. No, because exactly 2. You're right. If I said at least 2, it'd be 2 or 3. And that's a good point. All right? And then, of course, from there you can say, what's the probability that I get no heads?
1.
1 out of 8. Everybody see what I'm saying? All right? So we can make up lots of problems based on that. All right? Now I want your eyes up here real quick. All right? This is trying to teach you about the fundamental counting principles, what they tell us. And how many times did we flip the coin? 3 times. So now I want you to look up here. All right? I knew it was 8 already because we're doing 3 different events. All right? So here's what I want you to write down next, right next to your tree diagram. Now, the fundamental counting principle is simply telling you how to figure out how many total there are. So when you flip a coin, how many options are there? 2. So we put a 2 right here. You flip the coin again, how many options do you have? Nope. Still have 2. You flip it a third time, how many options do you get? 2. Now, what the fundamental counting principle says is if you want to figure out how many total different events there were, you just multiply them together. That's exactly what the fundamental theorem of, or the fundamental counting principle says. So what is 2 times 2 times 2? 8. That's how I knew there were 8 different possible outcomes. All right? Is everybody good on that? That's a really cool little thing. And so I used to just show the shortcut without actually demonstrating the tree diagram. And I think the tree diagram just helps you work on seeing patterns. That's what we're interested in. Yes, sir.
What if like a coin landed in a crack and that would be like...
Yeah, so now that's a good point. That's a good point. So we say, right, that if it's a fair coin, it has to either be a head or a tail. There aren't options to what happens if it doesn't flip properly. Okay, so we kind of exclude those events. All right, what?
For number 2.
I'm not on number 2 yet, but, all right, I'll be right there and you can tell me. All right, now again, like I said, we got 2 days to cover this because today's kind of a short day. Does anybody have any questions with that tree diagram? Super, super important for understanding probability. All right, now, Bradley, let's scroll over to number 2.
12.
So now we're going to take a number cube and flip a coin. How many outcomes are there? Bradley, there are 12 outcomes. Now you might be able to tell me what the outcomes are. What are the outcomes without doing a tree diagram? You could get a what? 1 and a? No. That's why the tree diagram is important. What are the outcomes? Do you know, Jack?
Would it be? I feel like it's like there's a.
Remember, you're doing 2 things. What are your possible outcomes?
What's a number?
Yeah.
The dice.
Oh, okay.
Oh,
Then
All
it's
right, a cube. You're throwing a cube. So your outcomes could be, listen,
1H, 1T, 2H, 2T, 3H, 3T, 4H, 4T, 5H, 5T, 6H, 6T.
that's exactly correct. That is exactly correct. All right. Now, does it matter if you put the 1 and the H first or the H and the 1?
No.
Makes no difference. All right. But what's important is that you're able to see that. All right. Now, eventually, we're going to say, like, if I throw the dice 3 times, how many possible outcomes are there? There are actually 216 different outcomes when you throw the dice. All right, how did I know that? Because I know what 6 times 6 times 6 is. But right now, here's what I want you to do at the top here. Just what Bradley did. We're doing 2 events. Does everybody agree with that?
Yeah.
Wait, is it 2 cubes?
No, just 1. A number cube. So how many options are there for the cube? 6.
Or, yeah.
And how many options are for the coin? 2. So your fundamental counting principle says you're going to multiply them, so you're going to get how many different outcomes? 12 outcomes.
Wait, so
There
if
are,
it's like, because I got 262 because there's 2 events and then.
no. The events. This actually represents the event. Here's your first event. Here's your second event. That's where that second 2 is coming from.
Oh.
Okay?
Oh, okay.
Now we're going to try to draw the tree diagram. So the cube comes first. How many options do we have on the cube? 6. And how would I list those options? That's exactly right. So at the top, 1, 2, 3, 4, 5, 6. Beautiful. All right, that's your first selection. Your second selection is when you flip a coin. And how many outcomes do you have when you flip a coin? 2. So you're doing your branches here. And then each coin can be flipped as a what? Head or tail. So you put H, T, H, T, and so on. Come on now, guys. That's really, really important. So here's how he said it. But he has it in his mind, and everybody else should have it in your mind also. So now, if I had to write out all 12, you would simply say 1 H, 1 T, 2 H, 2 T, 3 H, 3 T, 4 H, 4T, 5H, 5T, 6H, 6T. Is everybody with me?
Yeah.
So that's what we have. And if you count those, there would be how many there? There would be 12. Come on, guys, I think that's pretty easy. All right, very good review. All right. Now, what I'm going to do is I'm going to make sure everybody understands about a deck of cards because not everybody understands decks of cards either. Yes, ma'am.
Do you have to write the tree up and just do
No, this for me is important. So I wanted you to draw out the tree diagram. This right here is the tree diagram. And honestly, everything else was extra. All right, when they say draw the tree diagram, I'm going to make you draw a tree diagram on the test. All right, you're going to have to organize your thoughts. This really is helpful in organizing your thoughts and seeing patterns. That's why it's important to be able to do that. All right, so now we're going to talk about the standard deck of cards. All right, some people know, some people don't know. So if you don't play cards, I understand why you don't know. All right, but let's talk about the deck of cards. Let's just make sure everybody knows. In a deck of cards, how many cards are there? Does anybody know? There are 52. All right, so let's put 52. Does everybody understand there's 52?
Yeah.
Right, now in your deck of cards, there are how many different colors? Two different colors, right? So we would say in the deck of cards, there are red and there are black. Is everybody okay with that? And then there's the next thing called suits. There are 4 what?
There's heart, spade,
Help him.
I don't know the other-
Clubs.
clubs and diamonds.
Clubs and diamonds. So there are 4 suits. And I want you to remember clubs, diamonds, hearts, and spades. All right, those are your 4 suits. Now, because there are 4 suits, how many of each suit are there? How many of each suit?
13?
13. Very good, because 52 divided by 4 is 13 if you forgot. But there are 13 hearts, 13 clubs, 13 spades, 13 diamonds. Everybody with me? Now, there's some special cards in the deck. Those would be
Two
the...
jokers.
No, we're not doing jokers.
Kings, queens,
Kings, queens, and
jack, aces.
jacks. And there are face cards. All right, and basically a face card is anything with a what? Face. All right, the king has a face, the queen has a face, and the jack has a face. So we call those the face cards. So there are 3 in each suit that are face cards, and there are 4 suits. So that means that there are how many face cards, Bradley?
There
Say it.
are
12. He just wasn't listening. All right, there are 12 face cards. And then the other special card is the what?
12.
Ace. And remember, sometimes the ace counts as 1, sometimes it counts as 11. But for us, we don't really care about that. All right. Now, ace can be considered a 1. And then there is a 2, a 3, a 4, 5, 6, 7, 8, 9, 10. And then the jack, the queen, and the king. Is everybody with me on this?
So we're not counting.
Yeah, we're definitely not counting jokers. All right. Those are just the 52 card deck. They call that the standard deck. All right. Did I have to leave anything else out? Base cards. We did the suits. All right. And again, now we can answer these questions. Let's see about these questions now. It says here, find the total number of outcomes. If you want to draw one card, how many different outcomes are there? Yes, 52, because there are how many different cards in the deck? 52. So everybody put 52 down. All right. Now remember, as soon as you don't understand something, I totally get that. You don't play cards. You may not know. All right, so I got to help you with that. All right. So, I already said this. If 3 6-sided number cubes are rolled, how many outcomes are there? 216. Now, here's how I want you to do that, guys. I want you to put a space, space, and a space. Every time you roll the dice, it's how many options? 6. And then you roll it a second time, how many options? Third time. And fundamental counting principle says, what do I do? Multiply. 6 times 6 times 6, now everybody knows is what? There are 216 different possible outcomes. All right? Let's look at number 5. One coin is flipped 3 consecutive times. How many outcomes? How many?
There's 8.
8. Right? So here's what I want you to do, guys. 1, 2, 3. That represents flipping a coin 3 times. How many outcomes do I have every time?
3.
How many outcomes? 2. 2, 2, 2. Then I want to put a multiplication sign in between and tell me there are what? 8 total outcomes. 8 total outcomes. All right, number 6. Let's see if we're getting smarter. One coin is flipped and one 8-sided dice is rolled. Is there such thing as an 8-sided dice? Actually, there are. Right? There's special die, yes. There are 16-side. There's 20-sided dice. You can create any side you want. All right? So, if you have one coin and one 8-sided, you have how many different possibilities for a coin? 2. And for your die? So you have how many outcomes? 16 outcomes. All right, we're doing good. All right, hopefully it's making sense. All right, number 7. A sweater comes in 3 sizes and 6 colors. How many sweaters can you make?
Can't there be 24?
Why 24?
There's there'd be 3 different sizes.
Times what?
Times 6 different colors.
3 times 6 today is?
24.
Wait a minute.
18!
Oh, man, Diesel, you're killing me today. All right, he is correct. His process is correct. We just forgot what 3 times 6 was. So again, this is how I want you to look at it now. All right? Sweaters come in 2 sizes. They have, thank you, 3 sizes and 6 colors. So you can make how many different sweaters?
18.
18. Thank you. 18 different sweaters. Ian, you all right back there? You didn't kind of say it too positively.
I just want to get more questions.
What?
I want more questions.
Okay, good. That's good. All right, so let's look at number 8.
I'm starting to
All right, here we go. It says a restaurant offers dinners with a choice each of 2 salads, 6 entrees, and 5 desserts. So, oh my, tell me what the answer is. What do you mean you don't know? How many choices do we have here? How many choices?
2 salads.
That's right. That's right. You have 3 selections, though. Do you agree with me?
Yes.
And in your selections, you have a choice of how many salads can you choose from? Shh.
2.
2. How many entrees? 6. And how many desserts? 5. Fundamental counting principle says we multiply those. And if I multiply 6 times 5, and then times 2, there are 60 options. All right? So if that's what you're offering at the restaurant, you have 60 dishes that you could possibly create. Is everybody okay with that now? All right, hopefully you're feeling better about it. All right, let's take a look at number 9. All right. How many ace of spades are there? 1.
150.
Leighton, what's my answer for number 9?
If there's 52 cards, there'll be 1 out of 52.
100% correct. 1 out of 52. That's correct. All right, number 10. Uh-oh. A coin is tossed twice. What's the probability of getting 2 tails? Who can tell me? What do you think? 2 out of 8. What do you think?
2 out of
2 out of 8. What do you think?
2 out of 8.
Come on, you got to think for yourself. What do you think? Yes. Calculate it. Yes. Somebody else want to give me a shot? What do you think? Come on now. You're tossing coins. You flip it up 2 times. What's the probability that they're both going to be head? 4 out of 8. Say it again. Say it. 2 out of 4 is not a bad guess. What do you think? 4 out of 8. You already said. What do you think? What are you thinking, Thomas? Aiden? 2 out of 4. Good. 1 out of 4. What are you thinking? Okay, so now here's where we got to figure this out now. Come on, how many times are you flipping the coin? Twice. So how many different outcomes are there? 4. So the denominator has to be a 4. The denominator has to be a 4. No 8 involved. Now, what are your outcomes when you toss a coin once? You get a what? Heads or a what? Tail. That's the first time. Now the second time you can get a what? Head or a tail. Head or a tail. So all your possibilities for flipping a coin would be H, 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 T, T, H, or T, T. That's what we're interested in. Come on now. What is the probability of getting 2 tails? 1 out of 4. 1 out of 4. Does everybody see that now? All right. Everybody see that? What?
So on a test that would have been wrong because like.
Yes. It's wrong. That's why you have to recognize.
Reduced, right?
1/4. What do you mean?
4/8.
Seriously, 4/8 reduces to what? 4/8 reduces to what?
1/2.
Thank you, man. All right. Don't feel bad. I know you're thinking. 4/8 reduces to 1/2.
Oh yeah.
All right. Now let me make sure I get my computer charged up here before it goes dead. So be patient.
Well, technically 2 H's, right? Because if you're thinking about reduction again.
Yeah, I just forgot to do
Yeah, 2 8s. All right. Here we go. So now let's take a quick look at number 11. Okay. So who's got number 11 now? What do you think, Jack? What?
1 out of 52.
1 out of 52. Why is it 1 out of 52? There's only 1 6 of clubs. Ian, are you still with me? So it's 1 out of 52. All right, that wasn't too bad. All right. Now, number 12. What's the probability that you get a 4 or higher on a 6-sided dice? Tell me, Aiden. How did you get that? Four? Tell me again. I want your explanation. I'm not saying you're wrong. I want to hear your thoughts, buddy. So what's the probability to roll a 4 or higher? So give me the numbers that are 4 or higher.
4, 5, 6.
That's correct. Out of how many possibilities?
6.
That's correct, buddy. I wanted to hear what you had to say. 3 out of 6, which is, reduces to 1/2. Everybody okay with number 12? Good job. All right, let's look at 13. You want to roll a 7 or 8 on an 8-sided dice. Thomas, what's your probability for rolling a 7 or 8 on an 8-sided dice? Right? So how many 7 or 8s are on an 8-sided dice? Where are you getting 15 from? Thomas, come on, Thomas. Thomas, come on. I don't care. Thomas, sit up. Come on now. Come on. Come on. Nothing. Everybody's working hard. How many numbers are on an 8-sided dice, Thomas? 8. Now, how many on that die are a 7 or an 8? 2 out of how many? Thank you, Thomas. There you go, buddy. Come on, man. 2 out of 8. And if I ask you to reduce that, you would say it reduces to what? Yes, good. Come on, Thomas. 1 out of 4, buddy. You have a lot to say. Speak up. Speak up. Speak out. Come on. I know you're not that shy. I hear you screaming hard in the hallways. Mr. Comedian. All right. I want to roll an even number on an 8-sided dice. Tell me. Everybody has to write 4 out of 8. And then we're going to reduce that to what?
1/2.
Yes, 1/2. All right, let's look at question. Uh-oh. Now a little bit harder. Bradley, if I want to draw a club from a standard deck, how many clubs are in the deck? 12?
11.
11? I think it's 13, isn't it?
Yeah.
13, right?
Oh, yeah, I did.
So there are 13 clubs out of how many? 52. Now, some people thought this was hard, but really, how many suits are there?
There's
4 suits, and how many of them are clubs?
1.
1. So the correct answer really could have been much easier if you'd have just said there's 1 out of 4. But what does 13 out of 52 reduce to? 1 out of 4. All right, we have a great question coming up. Go.
Are we gonna need to know that?
That's why we're reviewing it. I don't know why people ask me what is on a test. Generally, what's on the test is what we do in class. That's generally how it works.
So we are gonna need.
What do you think? Yes, of course. Everything on here, you're going to have to know. All right, that's why I'm trying to make it clear. If you don't understand what a standard deck of cards is, I want to make that clear. If you don't, go ask your parents to buy you a deck of cards and kind of look through and you can see what I mean. You don't even have to. You can go to your computer and look up standard deck of cards and it'll show you exactly what that means. All right. Now, number 16. What's the probability that I roll an odd number on a 6-sided number cube? Thank you. 3 out of 6. Perfect. So I want everybody to put 3 out of 6. Then we're going to reduce that to. Thank you. Very good. All right, let's take a look now at 17.
I have a question. Why did they call them number cubes and not like dice? 'Cause
Well, a cube is what a dice
Isn't
is.
it die?
Yes.
Isn't it? Why,
Singular is die. Plural is dice. So when you're talking about a die, it's actually a cube. That's the geometric shape. You with me? And a cube has 6 sides. They just put the numbers 1 through 6. All right, good question. Number 7. It says a coin is tossed and an 8-sided die is rolled. All right, so how many events do we have? We have 2 events. And how many numbers are on the first die? A coin is tossed and an 8-sided die is rolled. 8. So how many possibilities are there? There are 16 possibilities. What is the probability that the coin lands on a tail and the die lands on a 2? Ian, what are you thinking? Now here's what I want you to do right now, guys. If this is your possibility, I'm going to erase this real quick so I can show you something. All right, listen what I'm trying to get you to do, Ian. All right, I really want you to pay attention because this really isn't hard, but some kids it is hard for. So I'm trying to make it as easy for you so you can see better. All right, so what are you doing? You're tossing a coin, correct? All right, and when you toss a coin, what are your options? That's right. You can either be a head or you can be a tail. Now you're going to roll the dice. How many options can you get? No. No, how many options for the... So how many options are there? 8. So when I say 8 now, you've got to come over here and say 1, 2, 3, 4, 5, 6, 7, 8. You see that? So you can get a head and a what? 1. Head and a. You can't, when you flip a coin, you can't get a head and a tail. Head and 1, head in, You understand my point now, right? What goes over here now? 1, 2, 3, 4, 5, 6, 7, 8. So I could also get a what? Tail and a, yes, tail end, all the way. So how many possible outcomes are there? There are 8 for the tail, and how many for the head? I see that. That's why I said you got your head down back there. I'm not sure what's going on, right? So look up here now, because look, I'm telling you one more time. Don't be frustrated with yourself. It's easy, but watch me. All right, I can get a what? Head and a 1. I can get a what? Head and a 2. Head and a. Or I could get a what? And how many outcomes is that then altogether? There you go, buddy. You with me now, right? So now you're in the game. So we have 16 possibilities. Now for those possibilities, I want to know what's probably that you get a tail and a 2. How many of those outcomes have a tail and a 2? Shh. So tell me the options I can have right now. What are my options? All 16 options. They can be a what? No, those aren't options. Those are possibilities. What are my options? Head and a number. I'm trying to help you. Head and a 1, then a what? Head and a 2. Now listen to me. The most important thing, Ian, listen, you're not hearing me. Listen to me. I don't care about that right now. What I'm trying to do is, you got it a little mixed up. It's okay. Let me get it straight. Come on, man. Let me get it straight. I promise you, in a minute you're going to, oh, that was easy. Okay, so you can get a head and a what? 1, a head and a. Now let me make sure I'm writing this down. You can get a head 1, head 2, head 3, head 4, head 5, head 6, head 7. Is that good with you? I can also get a what? Shh, don't help him any. Yeah, there you go. Tail 1, what? I'm just writing them out. And again, let me tell you something. Honestly, that's where I was. I thought I understood because I never had to write anything down, so I wasn't very good at patterns. As soon as I started writing the patterns out, it was easy for me to do everything else. Do you hear me? Now, my question is, how many possibilities are there? There are 16 possibilities, and I'm counting them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16. You with me? Now, out of those 16, how many of them are a tail and a 2? Show me. What's an H stand for? Heads. I want to know the one that has a tail and a 2. 1. So that's all we're asking. 1 out of 16. Now hold up. I want to make sure you're hearing me on that. Does that make better sense now, right? So I'm asking specifically this. Tail and a 2. 1 out of 16. Do you agree? Now how did we get 16? Well, there were 2 choices and what? 8 choices multiplying together. All right, listen, we're going to continue tomorrow. That was pretty good, guys. Really, no homework except 18. Everybody has to do question 18. Everybody has to do question 18, and then we'll do the rest of it tomorrow. Good job, guys.